we have seen that how to find an invertible function. We have seen that when we can find the composite function if they exist. Similarly, inverse of a function can exist if and only if it is 1, 1 and onto. So if we prove that f is 1, 1 onto, then its inverse exists. Number one condition. And number two condition is f and g are two mappings like reverse mapping. If f is a mapping from A to B, actually the inverse will be the mapping from B to A with two functions such that G composite f is equal to identity function in A. So we used to remember like this: G O f x is equal to x and f o g is equal to y is equal to y. Then f and g are inverse of each other. Okay, these are the conditions how to find out whether it exists or not exist inverse function. Now we will see how to find out algorithm, how to find out the inverse of an invertible function. You know that we have to check first and then we can find out. Okay, so what will be the algorithm? So you can note down the algorithm. Then we will start some. We will take some questions. So now algorithm of to find the inverse of a invertible function. Algorithm to find the inverse of a of an invertible function. Invertible function. So if it is invertible, then only we can find out the inverse of an invertible function. Step number one. Obtain the function and check obtain the function and check whether it is 1 1 or odd 2. So that is object, that is bijective. Then check its bijectivity. That is 1 1 on 2. Bijective means 1 1 on 2. So if it is bijective, then only its inverse exists. So before finding inverse, we will have to check that whether it is invertible or not. Means 1 1 or 2. If f is a bijective function, then it is invertible, obviously. So we will write if f is a bijection, f is a bijection, then it is then it is invertible. If f is not a bijection, it is not invertible. We will stop here. So in order to find f inverse, what we will do in order to find the inverse of f, inverse of f function, we will put f composite f inverse. Here if f inverse x is equal to x and then solve it. That is what f of f inverse x, f of f inverse x is equal to x and solve it to get f inverse x. Step third, you can write separately. Step third, solve this equation, solve f of f inverse x is equal to x to get f inverse x. Means f of f inverse x is equal to x, we will write and find the f inverse of this function. Now we take one question. Show that f is a function from real numbers except minus 1. Minus minus 1 to the real number except 1. Domain is this except minus 1. Codomain is this. Given by, defined by fx is equal to x over x plus 1 is invertible. So that first it is invertible. Also find its inverse. Also find f inverse. Okay. So first we will have to show f is 1 1. So according to the step number 1, we will prove that f is 1 1. Here we are not putting minus 1 because minus 1 plus 1 will become 0 and right hand side you will get infinity. So that's why this side here we are not having minus 1. Otherwise, if you will put minus 1, so fx is defined by, so if you will put minus 1, this will become minus 1 upon minus 1 plus 1, 0, infinity. The infinity we cannot put here. So that's why this is showing r minus minus 1. And here also we don't have 1 minus 1 because 1 will not come from any number. So f is 1 1. That means we have f is 1 1. So for two elements we can take x1 x2 belongs to a domain of this function such that fx1 is equal to fx2. So x1 is what? X1 upon x1 plus 1 is equal to x2 upon x2 plus 1. Now cross multiply. We get x1 x2 plus x1 and x1 x2 plus x2. So x1 x2 cancel both sides. We get x1 is equal to x2. So fx1 is equal to fx2 implies that x1 is equal to x2. Therefore, f is 1 1. And second step, we have to show that f is onto f is onto. We can analyze first. Let y belongs to, take any element from codomain, then fx is equal to y. We will take fx is equal to y, and x is equal to what? X upon x plus 1 on y. That is that x is equal to, we'll find the value of x. I'll write here x into x y plus y, and this x minus x y is equal to y, and x is common. 1 minus y is equal to y. X is equal to y upon 1 minus y. We'll write x in terms of y, and then again we will write clearly is there is no element for all y belongs to the codomain there exists. This is the symbol for there exists. There exists x is equal to y upon 1 minus y belongs to domain r minus minus 1, such that fx is equal to y, such that fx is equal to y means we can put the values fx is equal to y means f of y upon 1 minus y will be equal to y upon 1 minus y upon 1 minus y plus 1, taking LCM y upon 1 minus y divided by 1 minus y plus 1 minus y plus y will cancel. This will also cancel. We get y. So x is equal to y. Also, x is not equal to minus 1. This is not equal to minus 1. Otherwise, it will become infinity. So, we get y is equal to y upon, that means y upon 1 minus y is equal to minus 1, or check for x is equal to minus 1, we get y, that is not possible. So therefore minus 1 we will not take. If you see this one, it is you can, if you are not understanding, you can skip this step. So we prove that it is invertible. 1 1 on 2. Next step we have to find the inverse of this function. Okay. So now how to find f is 1 1 and invertible. It is proved that therefore f is invertible because it is 1 1 and not 2. When it is invertible, we have to find the inverse of this function. So how to find the inverse? I told you that we will find by using this formula f composite f inverse of x is equal to x. Right? So and f, you know that fx is equal to here in this question fx is equal to what? X upon x plus 1. Okay. So now f composite f inverse of x is equal to x implies that f of f inverse x is equal to x. And you know that fx is equal to this, so f inverse x will be equal to f inverse inverse x upon f inverse x plus 1 according to the given definition. So this will become f inverse x divided by f inverse x plus 1 is equal to x, and find the value of f inverse to get the inverse. So f inverse x is equal to cross multiply, you get x into f inverse x first x. If you have to transpose f inverse x on left hand side, so minus x into f inverse x is equal to x, or f inverse x is common. If you take f inverse x common, it will become 1 minus x is equal to x. Therefore, inverse of this function f inverse x will be equal to x upon 1 minus x. This is our answer how to find the inverse. Okay. And this is the first method in which we have used 1 1 on 2. And second condition, I told you there is one more condition to prove that it is 1 1 on 2. That is this one. G of f of x is equal to x, therefore g of y is equal to y. If we prove these two conditions also, then it is also inverse function. Then we can find the inverse of that function also. So the same question can be solved by the second method. Same question we are doing by the second method. Okay. So second method, this is our second method of doing the same question, where we will use g of f x is equal to x. Okay. So now we will take first whether it is g of f x. Find this. So this will be equal to g of g of fx, g of fx is equal to x, and definition is here fx is equal to x upon x plus 1. So g of fx will be equal to, what is the value of fx here? Fx g of fx is equal to x, then fx is equal to x plus x upon x plus 1. Fx is equal to x upon x plus 1. Okay, then it will become g is what will be the g? Yes, fx is equal to x upon x plus 1, because f is a mapping. Here we have to suppose a to b and b to a. G will be the mapping from b to a. Okay, so how we will find g? First we have to find g. For that one, it is very easy. If you will replace fx by y, fx is equal to y for finding g. Fx is equal to y x upon x plus 1, and find the value of x in terms of y, that will be g. So it will become xy plus y is equal to x, and x is taken left hand side xy, or it can be taken right hand side x minus xy is equal to y, and x common, so 1 minus y, so y upon 1 minus y. So this will be your gy. Definition of gy will be y upon 1 minus y. In this case, we will have to do this first step, step number 1, and then step number 2. So replace fx by y and find the value of x in terms of y. That will be the inverse of f. Actually, this is the inverse of f, because this is the mapping from b to a. A to b is a mapping from uh, is a mapping given f. Then then inverse will be b2a, opposite of that one. This formula will be used here for g x upon x plus 1. Okay, so this will come to x actually. So right hand side should come x. So we should not take this right side. We have to solve this and to bring it equal to x. Okay, because we are going to prove it equal to g of fx is equal to x. Okay, so this will be equal to, according to the formula, y means x upon x plus 1 divided by 1 minus y is x upon x plus 1, and when you solve x plus 1, when you solve it, this will become x plus 1 minus x, x cancel, this x plus 1 will also cancel, you get x. Okay, then after that you have to find out f of gx. Third step, you will find f of y. It should be equal to y. Okay, then it is invertible. So f is f of, you can write f of dx dy, sorry, f of dy, and now dy is y upon 1 minus y, and f is x upon x plus 1. So this will become y upon 1 minus y upon 1 minus y plus 1. And solve it, you will get equal to y. So therefore, we can say that g of, therefore we can say that, like this also we can write g of fx is equal to ix, means identity function in x, and f of g y is equal to identity function in y. Okay. So therefore, inverse of g, which is proof that inverse exists, and inverse of g is equal to, therefore, inverse of f. We are finding inverse of f. Inverse of g is f, and inverse of f is g. So therefore, inverse of f is g, and g is what? This is g. So this is the inverse of the function f. Therefore, we can say f inverse y is equal to y upon 1 minus y for all y belongs to real numbers minus 1. So this is the second method. So it is up to you. You can use any method. But if it is mentioned, then we can have to use the composite function. And there are other questions also. And inshallah, I'll take extra period later on after Ramadan to cover it. That's all.